Okay, so in this video, we are looking at limits. So, what is mathematical limit? So, in order to talk about limits, let's look at the below example here. X squared minus all over. Let's work out when what x is equal to when x is 1. So I sub in x. That's no bueno, no bueno. We can never divide. Okay? So that is going to cause a little problem for us. So that is known as undefined. So let's try another way of finding out what this do. Instead of trying to work out x equals, let's approach x equals 1. And as my x value gets closer and closer to, so when x equals 0.5, my equals 0.5, 0.9, 1.9, 0.99, a function 0.999. Then when my function is 0.999, my function 1 1.9999999. So as we see here, the closer and closer my x value getting to 1, the closer and closer getting to. So we say that the mathematical limit of this function with x 2. So even look at the little graph here, right? So look at the graph here. So here's a plot of x squared minus x plus 1. So it's handy dandy, la 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 la, going up, boom, 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 boom. But when I get to x equal to 1, whoop, up. The gap in my function here, this is known as a non-continuous graph. There's a little gap here, but we can see on my function getting closer and closer to 2, right? But it never quite limit of the 2. So when x equals 1, we don't know the answer because there's a gap there, but we can see it is going to be 2. We want to give the answer 2, but we can't, instead mathematicians say exactly what it's going on by using a special word limit. So the limit of x squared minus as x approaches 1 equals 2. Written in mathematical notation is the lim x x arrow 1 of x squared minus 1 over x minus 1 is equal to 2. So now we're going to start with the base of what limit is. Let's start calculating. So the limit of a function is the value of a function. Is the value that that function approaches as input approaches a particular value. So in limit notation, limit of x to a of f of x equals, i.e., just means my function goes to the value p when x goes to a. So there are certain rules, and when it comes to functions, don't fret too much about them. It just means if I'm adding two functions, I can take the limits of each function separately and add them together. If I'm dividing two functions, I can find the limit of the numerator and denominator. If I'm multiplying two functions, I can find the limit. I can multiply two limits together. And if I have a square root of a function, I can just find the limit of the square root. But the limit of a constant is just that constant value. So let's go back to our point here. So sometimes we calculate the limit and we end up with 0 over 0. This is called the indeterminate form, right? In these cases, we factorize the function before applying the limit. So let's look here, x squared minus 1 over x minus 1. That is going to be 1 minus 1 over 1 minus 1, which is 0 over 0. That is the indeterminate form. So we need to factorize. So my top is different to 2 squares. So I can factorize x plus 1, x minus 1. All over x minus 1. They cancel out. So I'm going to have the limit as x approaches 1 of x plus 1 equal to 1 plus 1, which is equal to 2. What we were able to prove above there in a graph, right? But here we go. I prove it mathematically that it's equal to 2. So let's just look at a few examples here. So looking at this one here, find the limit of this function here, 2x squared plus 5x minus 7 over x plus 3. Well, if I sub in x is 3 here, 2 times 3 squared, which is 9, 5 times 3 minus 7, all over 3 plus 3, 6. I'm going to get here 18 plus 15 minus 7 to 26 over 6. My answer is 13 over 3. Limit is 3. What about this function here? If I sub in x goes to 4, I'm going to get 16 plus 4 minus 20. Oh, that's going to be 0 on top and 0 on bottom. Uh-oh, indeterminate form, I need to factorize. So if I factorize the top here, 2 knows to multiply to get minus 20, but add to get 1. It's going to be x minus 4, x plus 5, all over x minus 4. The x minus 4 will cancel. The limit of x goes to 4 of x plus 5 will be equal to 4 plus 5, which is, right, 2 more. X squared minus 5x minus 14 over x minus 7. If I sub an x to 7 here, I'm going to get 0 over 0. I need to factorize. So it's going to be x minus 7, x plus 2, divided by x minus 7. Ding, ding. So the limit, x goes to 7, x plus 2, 9, because, right, one more one right here. X cubed minus 8 over x minus 2. Sub in x to 2, I'm going to get 0 over 0. So I need to factorize this as different cubes. The x minus 2 times x squared plus x all over x minus 2. They're going to cancel out. I'm left with limit of x goes to 2 of x squared plus x 4 equal to 2 squared plus 2 times plus 4. That's going to be the mathematical limit of this function when x approaches 2. Fine. Now let's consider something else. What about when my function goes towards infinity? Right? So consider the function 1 over x. So when x equals 1, my function equals 1. 10, 0.1. 100, 0.01. If I keep going and increase my values of x, right, my answer gets smaller and smaller and smaller. So we say that as x increases to infinity, the function tends to 0. So we need to remember now, if I have a function 1 over x and the limit is going to infinity, it goes to 0, right? Especially if it's 1 over an extra power, it goes to 0. A constant over x and it goes to infinity, it goes to 0. So, but the only thing is, in general, to calculate the limit to infinity, we must divide the numerator and the denominator by the highest power of my variable. That is what we need to do first, and that allows us to then take advantage of these rules. So I see here, x to the power 2 is my biggest one. So I'm going to divide every term by x squared. That's going to be x over x squared minus 4 all over 9 plus 5 over x. As the limit of x goes towards infinity, well, 8 over infinity goes to 0, minus 4 all over 9 plus 5 over infinity, well, 0. The answer is minus 4 over 9. There's one more here. I see here my biggest power of is x to the power of 5. Divide everything by x to the 5. That's going to be 1 over x squared minus 2 over x to the 4 plus 11 over x to the 5 all over 3 over x to the 5 minus 6. As we go into infinity, my numerator is 0, 0, 0 all over 0 minus 6 is going to be 0. So my limit, this function, is equal to 0. Right? So let's look at two exam questions here. So this is from 2023. So I have now, I'm adding three functions together, but remember the limit of the limit of a sum is the sum of the limits. So I need to see here n over n plus 1. Well, my highest power of n is just n. So n divided by n is 1, n divided by n is 1, plus 1 over n, plus then n divided by 1, n divided by n is 1, 100 over n all over n divided by n, which is 1, plus 1 over 3 to the n. 1 to the power of n, but anything, 1 to the power of anything is equal to 1. So we can leave that as 1 over 3 to the n. Now we're tending towards infinity, so limit when n goes to infinity, that will be equal to 1 over 1 plus 0 plus 1 plus 0 over 1 plus 1 over an astronomically big number, which would be 0. So I'm left with 1 plus 1, 2, 2. And then the last time that came up before that in the junior cert was 1993, so 30 years prior, right? To find the limit as x goes towards infinity, I see here that x squared is the biggest power of x, so it's going to be 2 plus 3 over x plus 4 over x squared all over 1 minus 2 over x minus 3 over x squared. And that's the limit of x tends towards infinity. That's going to be 2 plus 0 all over 1 minus 0, right? All of these terms go to 0. So I'm just left with 2 over 1, right? And that is limits. I hope this video was, and I'll catch you guys later. Bye.